Hey guys.
Let's begin. I haven't the official go, but you can begin.
Okay, we're starting.
We're unofficially beginning to talk now. So, thank you guys all for coming here. We really appreciate it. This is going to be our talk called Sonar Smash, Fueling the Removal of Technical Debt Through Competition. It's going to be roughly around 35 to 40 minutes, and we'll give questions, but we promise all of you will get out for lunch. Straight off the bat, my clicker doesn't work. Class. All right. So, my name is James. I'm a software developer for Murex in Dublin. I've been working with them for the last 4 years. Started in kind of R&D, a little bit of Devoxx, and now I'm working as a feature developer on their risk control platform.
I'm Helen. I also work in Dublin for Murex with James on the risk control platform, and I spend a little bit of my time on the Devoxx team as well. So, a few of you might have heard of Murex, a few of you might. So, who are Murex? Murex make a capital markets platform for banks. What are capital markets? That's how banks trade with each other. Specifically in Dublin, we deal with the riskiness of those trades. The Dublin office has been writing this code for about 15 years, which means we all have very nice jobs and well paid. But it does mean that some of that code is a little bit old and a little bit confusing and has kind of decayed over time. So that's kind of where we stand, and that's what you need to know about our company. So for this talk today, I'm going to give you some context about the words we're going to use and what they mean. Then we're going to talk about the problem we had in Dublin, the competition we made to solve that problem, and then we're going to dive into like the aspects of the competition and how you can use them to build your own competition when you leave here. And then some lessons we learned along the way, and we should have some time for questions at the end. So first up, this is not a talk on how to refactor code. There are plenty of resources online, and I'm sure there's some talks at Devoxx here to teach you how to refactor code. It's also not a talk on SonarQube. SonarQube, the SonarQube guys are here, is a tool we used to kind of fuel our competition and give us metrics, but it's not a how-to. I'm sure the guys at the SonarQube stand can show you all the features of SonarQube much better than I can. So, first up, legacy code. This is a problem we had. First misnomer, legacy code is not necessarily old code. You can have legacy code that's only a year old. It just needs to meet these two criteria in my opinion. So it needs to be untested and confusing or unclear. That means when you open the class, you have basically no way to instantly know what it's doing. You open it and you're going to have to just dig and sift and try and figure out what it was supposed to do to begin with. This makes adding new features or fixing any bugs quite difficult. So that's the problem with the legacy code. What's SonarQube? SonarQube is a static code analysis tool which will tell you kind of issues you have in your code. It'll take a class like this and point out all the issues that you have and kind of give you an explanation of why they're bad. If you want a kind of real world parallel, if you take Microsoft Word and then run spell check, that's kind of what SonarQube is doing. As a good developer, you're probably able to spot all these issues yourselves, but when you have like 1.5 million lines of code like we had, no one has time to do that. So SonarQube also has these nice views where you can kind of sort your issues in terms of what kind of issue they are and how severe they are. So are they a very high security issue, or is it just a variable has a bad name? You know, maybe you don't really care about that. So that's SonarQube. And we'll talk about issues, rules, violations. They are all the same thing. It's like this list of things that have gone wrong in your code somewhere along the lines. So Sonar is not the only one you can use. There are other things. You can use SEML, which has kind of similar functionality. I haven't used it myself. Jacoco, which is, if you just want to focus on code coverage, Jacoco has everything you need. Black Duck is another tool you can use. I'm sure there are many others. There's only really two criteria. They need to give you fast feedback, and there needs to give you a metric that you want to improve. So for example, if you were using Jacoco, it gives you the metric of code coverage, which is what you want to improve. So.
All right. So I'm going to tell a story now that I think a lot of developers will be able to relate to. So you go into work on Monday morning, and you're going to work on a new feature in an old part of the code. And you're like, cool, I've never worked there before. Let's go see what that's like. And you open up the code, and the class has 15 parameters, and you're like, oh, okay, well, don't really understand why that's there, but okay, well, let's take a look at the body of the class. Let's see what's going on. And for some weird reason, there's 3 nested while loops, and 2 of them are while true, and oh my god, okay, all right. Let's just go to the tests. The tests will explain everything. And why are there no tests? Why didn't this guy write tests? What the hell is going on? And really, you don't want your developers to feel like that. You want your developers to feel like this. So we realized that our problem was we had all of this technical debt that had built up over years and years in our code. And a few of us were like, okay, let's start looking at Sonar. And let's start figuring out ways to get rid of this. So we spoke to our architect, and he was like, I have a great idea. We're going to go through each rule one at a time and get rid of them. I really appreciate that reaction. And get rid of them. And we were like, this is a great idea. This is how we fix all of the code. And just going by the laughs in the audience, I think you'll realize where this story is going. It didn't work. So on Monday morning, we were like, this team, you're going to fix all the places we return null. You're going to fix all the places that we have while true loops. And we got really good at finding new ways to write while true that wasn't exactly the same. And we made Sonar happy. And we fixed like the surface level problems, but our code was still terrible in certain places. And we were like, okay, well, this isn't working. No one's enjoying doing this work. No one feels like the code is benefiting from us doing this work. So we thought, well, people are giving up. We need to find something that engages everyone, some way that they're like, okay, we want to do this. We're going to enjoy doing this. And we're like, well, let's take a really different approach and let's run a competition where, you know, we'll have something going on. People will feel the need to compete. And at the end of it, we'll be able to say which person is best. And anyone here who knows Irish rugby will tell you the captain on the right is best. So we told our developers to form teams, and we told those teams we were going to score them on how much technical debt they removed. And the winning team was going to get free lunch. And that was it. That's all we did. And we've run this competition 3 times now, and every time we run it over 2 months. And this is the results we have. So we've run it across 3 offices, involving over 50 developers, 230 classes fixed, over 1,000 issues removed, and we have 7,000 lines of pre-existing code brought into test coverage for the first time. And, you know, to me, I always find that amazing. I always think that we've done such good work so far.
So that's a great story and all, but like, how do you take that away? So we've broken the competition down into like 6 kind of key aspects of running a competition. And if you think about them in relation to your company and your problem, so your problem might not be technical debt, maybe it's code coverage, then you can run your own competition. So the first one, quick fixes. These are things you should do off the bat before you even try and run a competition. The mechanics of a competition. There are a lot of games that fail. There are a lot of games that succeed. Why is that? Feedback. You're going to get good feedback. You're going to get negative feedback. How do you deal with that? How do you motivate developers? I mean, free lunch is kind of lame. I'm going to be honest. I could just buy lunch. What is it? How did we get people to do it? How do you focus the effort of your now motivated developers to get the biggest impact? Because we got developers to do this on kind of downtime, and we got a good return, but like, how? And then building a competition to last. If you had a problem as big as us, we weren't going to solve it in one competition. We had to run it again and again. So how do you build a competition that you can run again and again? So first up, quick wins. So maybe if you have a large amount of code and you run Sonar, this is maybe how you feel when you first run it. You look at the results and you just want to run away. When we first looked at Sonar, having not looked at it for quite a while, I think we had 30,000 or 3,000 days of technical debt or something a bit insane like that. And we thought, oh, that's like 10 years. Oh, how did that get so bad? So the first thing to do is filter your metrics. So in Dublin, we said we have a new framework for our GUI. We're not going to look at the issues in our GUI code because we're going to redo all the screens soon enough. So we just stopped running Sonar on our GUI code, and then we only had 2,000 days of issues to look at, which was a bit more, it's still a lot, but it's more approachable. So then we started to look at all the Sonar rules, and we noticed that some of them were very good, but some of them just didn't apply for us. So one that I can think of is, there was one that said you should always throw a dedicated exception. We don't do that. We have a set of exceptions that we use, and we were happy with that. We didn't want to change how we did that, so we said, let's just turn that rule off. We don't care about it. And then at the end, we had a rule set that looked at the code we wanted to look at, and we actually cared about fixing those rules. The next thing we noticed was that some of those rules kind of really basic, and I kind of thought, like, I could probably write a script to fix that. And then I thought a little bit harder and said, someone's probably already written that script for me. So a lot of your IDEs, like Eclipse and IntelliJ, and probably Visual Studio as well, will have stuff built into them to do quick fixes. These are great because you can like do them in an afternoon and fix thousands of issues, and you'll feel great about yourself. For like more complicated issues, there's this tool called WalkMod where you can do a little bit more of the scripting yourself, and that'll run across your code. Another tool for C++, which I haven't used, is Clang. The last thing we did was we used a tool called Unused Code Detector to detect all the code that we actually didn't use anymore. When you like have an old code base, there's probably features you put in years ago for one bank, and then you like actually deleted the way to get to that code and never got rid of it. So we got rid of all that junk hanging around. And at the end we had, like, our Sonar still looked awful, like, don't get me wrong, but at least it was like a tidy mess. And the Sonar, we could like stand behind the rules and say, yes, these are the rules we care about, these are the ones we want to fix. So that's quick wins. So now you have your metrics that you care about. Like, how do you build a competition around those?
All right, so at this point, I'm going to presume that the talk has been incredibly successful, and all of you are like, how do we run this? So I'm going to address you as such. So you want to run your own version of Sonar Smash. First off, don't do it on a rule-by-rule basis. That was the first thing we knew. We recognized it didn't work from the get-go. Instead, we were like, hey, let's do this on a class-by-class level, where developers can take the time to open up the class, maybe look at the commit history, see what was the original intention. They're like, okay, well, it used to be fine, but one developer just royally screwed it up. So maybe if we just refactor it this way, and now that I've spent some time working on it, I feel like I know the class well enough to write some tests. And we're like, okay, well, this is going to be a lot better. And for you guys, when you do run your own version of Sonar Smash, you might be like, well, it's too granular on the class level. Our code is too coupled. We need to be doing this on the package level. It's kind of up to you guys, what level you want to run this on, but you have to pick one and stick to it. So we knew in our competition that we had two kind of key priorities. We needed people to fix the issues to make the code more readable and easy to work on. And we couldn't really tell people to start submitting stuff without writing tests. So we're like, okay, we need a way to show our priorities to all of the developers and say, this is how the competition works, and this is what's important to us. So myself, Helen, and a few others got around a whiteboard, and we came up with this. And this is our scoring algorithm. And this is how we were going to score all of the classes that got submitted in the competition. And when you guys write your own scoring algorithm, what this will look like is up to you. Maybe you don't care about technical debt or code coverage. Maybe you care about security issues. And for everyone who manages to find somewhere where you can do an SQL injection, that person gets 10 points. And as well, as soon as we had this written, we put it up on our internal wiki and we showed it to everyone. And all of the developers then had a lot more faith in the competition because they realized that it wasn't this black box scoring system. They could now look at classes in a new way and be like, okay, well, that one's probably worth maybe 100 points and this one a little bit more. So it was the first steps of how we were going to empower our developers. Secondly, from the get-go, we knew this couldn't be anything but a team-based competition. We told our developers that to take part, you had to form a team. And there was two rules to that. One, you couldn't work with the same people you work with every day. You couldn't have a team that was just your sprint team. And this worked out really well because it meant that people in the office who were friends got to have a team together. We saw senior developers go team up with interns and say, all right, I saw that refactoring you did last week. It was terrible. I'm going to teach you how to refactor. And that was great. And it created a far better sense of camaraderie. But whatever problem you guys have in your office, it might make more sense if it's the entire office is one team and you're trying to hit certain goals, or it's people working by themselves. And our problem was so big, we knew it was going to be more of a marathon than a sprint, which means if it's a competition, there has to be facilities for comebacks. So if you guys don't know who this is Charles. Nice. This is Charles Lemaison. He's a really famous French rugby player who in 1994, in the semi-final of the World Cup against the All Blacks, managed to bring about one of the best comebacks and win the game. And it's an absolutely amazing moment of sporting history. But the cool thing is, you know, it put all of his team in the mindset of, we can still win, we shouldn't give up. So we needed to have something in our competition which made people feel like, okay, if someone got a load of points really early on for refactoring a load of easy classes and writing a load of tests, how do we keep all of the other teams in the game? And we came up with this 2-tier scoring system. And this is my advice on how you keep people motivated through a long haul. So with 4 teams, the most any team could get was 4 points a round. And this was decided by the points you got by refactoring and fixing issues. So as the competition played out, we saw that the scores that they got for each round eventually added up, and all the scores at the end were really close. It meant that people at no point were like, oh, we can't win this. Everyone felt like they could win, and it was neck and neck till the very end, and people kept working on it. And that's something to bear in mind when you run your own competition. So a question we get a lot is, when the hell are you going to run this competition in your day-to-day? You guys have jobs, you have features, there's other things to be working on. And if you ask a good developer, and when I say a good developer, I mean an honest developer, how much downtime they have in their day-to-day, the truth is somewhere between 40 minutes and an hour. And this is when you're waiting for your code to compile, you're waiting for tests to run, you're waiting for your manager to come over and pair with you on a difficult problem. So we said, well, why not give those developers something to do that isn't just Facebook or YouTube, and they can work on this competition, and they can take a break from this bizarrely complex issue with a deadlock and work on something really simple and do it then. And this worked really well. It meant that we were able to meet all of our deadlines and deliver all of the features we promised and run 3 of these competitions in the background. And that was really cool. So you've made all of your rules and you understand how your competition is going to work. But really the most important thing next is to see if it can survive scrutiny. And to do that, you need to go looking for feedback. So
once we had our scoring algorithm, we were a bit kind of excited, and we went into a meeting with a lot of different people in it, and we said, hey, we have this really cool competition, we're going to solve all our technical debt with it. And they were like, and our architect was like, that's a really bad idea, guys. And our testers were like, I don't like that at all. And our developers were kind of like, why should I ever work on that? Like, that just sounds like more work on top of the work I already have to do. And at that point, it was very tempting to just be like, oh, fine, we'll just always have legacy code. It's fine, like, I don't hate my job at all. You know. But luckily, James was a little bit more optimistic and said, look, I'm sure they have valid reasons. They're all very smart people. So we sat down with each of them, and we figured out what they were concerned about. So the testers were rightly concerned that we would put new bugs in the code. And before this point, we didn't have code coverage as part of our score at all. We just said, oh, people will write tests along the way. And in reality, that didn't really happen. So we added that in just to give them the extra incentive to write tests. And as a result, we actually fixed some stuff. The devs weren't really sure why they should take part. James is going to go into that in more detail, but we did have a bit of back and forth on like what exactly the prize would be, and one team wanted lunch and one team wanted a trophy, so we got both. And then like, how do you control this? Like, we had to put in like people set aside to do code reviews. We had to make sure that all the code would go through like the normal validation process before it went to the mainstream and that kind of thing. And then at the end of all of this, that room of people who had basically turned around and been like, no, your idea is stupid, that's never going to work. We're now a room of people who had kind of had an impact on how the competition was going to run. And so they became our kind of advocates when we went to go and declare that we were going to run this competition to the whole office. We didn't have to sell it to every single person individually. Those people who had doubted us and now had a part to play in the competition were like, actually, no, like we thought about this. We're going to put in tests. It's going to be fine. It's going to work really well. And they were our biggest advocates, which was really nice to happen. So we realized from this that we had been somewhat naive in how we had planned things. And we said, before we do a full-on competition, let's just have a trial run. So we got 3 developers. We got a guy who'd been around for 6 years, knew a lot of stuff. We got a guy who'd been around for about 2 years, and we got a really green intern. And we gave them our rules. We gave them a list of classes, said, you have 2 weeks now, like, go see what happens. We'll get something for whoever does the best. And we were like, yeah, come back to us with any issues. And on day 1, the senior developer came back to us and said, hey, I looked at that list of rules you gave, that list of classes you gave me, and I don't want to work on any of those. But I was working on this part of the code over here, and that's really awful, and I want to refactor all that and bring it into test. And we were kind of a bit like, oh man, like we just made the rules and already you want to change them. But we said, like, this is a trial, like, let's give it a go, let's see what happens. And he went and refactored that whole part of the code to, like, a greater extent than we thought someone would do in the scope of a competition, and brought it all into test and scored a load of points that way. The medium developer actually just got slammed with production issues, so he didn't have time to work on it at all. And that's where we got our like round-based system from. We realized that it's very realistic that someone will just be busy for 2 weeks, and you want to have the opportunity for them to jump back in later. And our intern, green as he was very excited. He took a load of the rules that I would kind of consider like boring fixes, and he just like ran through them all and racked up loads and loads of points as a result. And at the end, the senior developer and the intern had the same like ballpark amount of points, which showed us that even though they had very different levels of experience, they could run in the same race and compete together, which was kind of very reassuring for us. So I would highly, highly recommend, if you do decide to run Sonar Smash, to run this kind of trial. So maybe your office is only 10 people, so then your trial could just be 1 person for 1 day, see how it goes. If you're going to run it on a much larger scale than we did, maybe run a whole round with 50 people and see what happens. You'll definitely learn a lot. So you've got your feedback, you've got the go-ahead. You still need to motivate your developers to take part. Like, free lunch, really, James?
Okay, so not that long ago, there was a really interesting new Twitter or internet challenge that some of you guys might have heard of called Trash Tag. And basically what this challenge was you go to your nearest park or beach or public area that's full of rubbish. You take a photo of the rubbish, you clean up the rubbish, and you take a photo of you with the cleaned up rubbish in trash bags, and you put it on Twitter, and you get a load of likes, and everyone's happy. So when I heard about this, I thought, why weren't people doing this before? You know, surely there's people who are doing it anyway, but why did it take some guy on Twitter to make everyone get out there and clean up trash for the first time? And the truth is, it was because they were going to upload their photo, a load of people were going to see it, and they were going to get internet points. So technical debt is a bit like trash. We know it's there, we see it, we don't like it, but we really don't want to be the ones to clean it up. So, as we guys told you earlier, we told our developers that the winners would get free lunch and a trophy. And that's what happened. But there's kind of another layer to it than that. You know, when we were looking around the office, we realized that some people were taking part because we made the competition really visible. At our sprint demos, we'd always announce the winners for that round. And people would be there with their manager, with the architect, with their other teammates, and they really liked being seen as the winners. And of course, who doesn't? For other people, it was about being part of a team. You were working with people that maybe you always wanted to work with in the office. And you could show them what you're worth. You could show them skills that maybe you had that they didn't. And as well, developers just like to code. Like, they're so used to nowadays working on insane issues that require 3 meetings to plan how we're going to fix this, that if you give them something that they can just throw themselves at for 10 or 15 minutes a day, then yeah, they actually have a lot of fun doing it. And speaking of which, the competition was just fun. People had fun taking part in this. When we announced who was in the lead, it was fun. When there's banter between the teams, it was fun. And at no point did this ever actually feel like we were doing serious work. So for you guys, I don't know what the underlying problem in your companies is, but what it'll take to motivate your developers is really up to you. You guys might realize that, hey, you know, we live in France, our lunch is paid for. Why not say to the winning team, you guys get to go home at 4 o'clock on a Friday, but stop by the pub and we'll buy you guys around for winning. And when you crack that secret of how am I going to motivate my developers, you can actually deal with so many underlying issues in a really new way, and that's really cool. So you have all your developers riled up, and they're like a big horde of barbarians ready to charge at the legacy code, but sometimes you gotta point these guys in the right direction.
So how are you going to focus that effort? The first thing I would say to do is trust your developers. If they're really riled up to focus on one part of the code, let them do it. Like that senior developer did, they'll be really excited and kind of have like that frustrated motivation where they're like, I just want to make it better. And then they'll get used to like refactoring code for the first time. You'll start to see scores come up on that board. The competition will kind of get rolling. And then they're going to finish up their pet peeves and then come back to you, and you're going to have something to hand them. So for this, we knew we needed a list of classes. So first up, you can select using Sonar or whatever tool you're using. Sonar has a load of really nice views. You can list things in terms of what's the least covered, what's the most complex, what classes have the most issues. We looked at this, but our code base being so big, there were certain parts that highlighted like very high numbers of issues, but we actually didn't like work on very often. So we said, maybe there's another way to come at this. So we said, let's look at our submissions. So we used a tool called CodeMat, which is online, to look at the classes that we were changing the most over time. What does change, like, why would that be important? So if you're changing a class a lot, it says, maybe there's a lot of bugs in there, and also, maybe that's the class that my developers spend a lot of time looking at. So we got that list, and then we married it with like the Sonar metrics together to come up with like a hit list of the classes we wanted to get refactored. And then we published it online, something like this. And we made sure to like publish exactly what state the class was. So if I only had 15 minutes, I could just go to the wiki page and be like, this one has 2 issues, I can fix that now. And then we made sure people assigned themselves, so you didn't have 2 pull requests coming in at the same time and someone getting really pissed off. So that's how you make sure to focus the effort. So you want to look at like what exactly I want to fix, like is it coverage, is it technical debt, and then try and focus it on the code you actually work on every day.
Okay, so the first time we ran this competition, we managed to fix a lot of technical debt, but we still had a lot of technical debt left to fix. So you have to recognize that if you have a large problem that isn't going to be solved by one single iteration of your competition, you need to build something that will last several iterations that people will want to keep coming back to. And we noticed something funny. When we announced the winner in our system demos, it was a big thing. They got handed a trophy. They were told they had to make a speech. They didn't make a speech. And they went for lunch. And all of the other developers came up to us and said, when are you doing this again? And we didn't, like, we kind of sat and we looked at each other and we said, all right, it's going to happen in 2 months. And they're like, I want free lunch next week. We're like, no. It's going to have to be 2 months. And this is for a few reasons. One, we needed to give our code reviewers a break. We had some people who were working overtime on this, and we were like, all right, we need to give these guys a chance to work on some other projects that they were kind of interested in. As well, when you run your own competition, you want it to feel like a novelty. You want people to look forward to when it starts and to look forward to when it ends. But if it's on every day, then people will stop caring about it. So maybe it makes more sense for you guys to run a competition where the last Friday of every month, everyone just works on trying to fix these issues, and it's a bit of fun. Or maybe it's every 3 months you spend just a week doing this. For us, we were like, okay, 2 months is the perfect number. And we were like, okay, well, let's use these 2 months to try and figure out a way to make this a little bit bigger. And the really interesting thing was, around this time, we got approached by the non-technical members of our team. And our non-techies came up to us and said, guys, we see you doing this thing called Sonar Smash. It looks really cool. We eat lunch. Can we take part? And we were like, yeah, why not? Let's run a load of workshops where we teach these guys how to open Eclipse, how to check out code on version control, how to do really basic fixes, and even write a very primitive unit test. And we did that. And then the next time we ran the competition, all of the developers were like, whoa, what are they doing here? This isn't fair. And other ones were like, just to each other saying, we can't get beaten by people who started to code last week. But all of the non-technical team members were like, we have something to prove. And they did. Some of them did a lot better than our developers. And we even gave a prize to one non-technical member who managed to refactor the most classes out of all of the non-technical users. So the really cool thing that happened after that, so there was a lot of banter and a lot of teasing, but the competition ended, and we were going into a meeting to plan a new feature. And the devs were saying, guys, this is going to be really difficult. It's on a really old part of the code. We don't think this is going to be easy. And our non-technical member on our team took out his laptop. He opened the class in Eclipse. He went through it with the developers, and then he said, you're right. We're planning this in the wrong way. We need a new approach. And that was really cool, because now we had given someone the tools to have a conversation that wasn't happening before. And around the same time, one of the more senior people in our office who had been really against Sonar Smash at the beginning came to us and said, okay, we need to use this to try and meet some deadlines by the end of the year. I want you to start getting people to fix the most critical violations in the code. And this was really cool, because now we were using it to achieve office goals. And there's like this whole new thing. There was a new level to it of complexity. And very recently, we got a group of interns in the office to build a scoreboard that automated scoring. And it was like a really cool thing to do. And we have it now in our kitchen and work, in our break room. And people see it. And it's, once again, it's fueling this. It's getting people ready for the competition. So on the last note of how you keep something fresh, the reason Sonar Smash works so much is because we made it fun. The last time we ran it, when we were running it with the non-techies, we had this whole Avengers theme of, you have to have a team of diverse people. Now with Game of Thrones, we're making all the teams have like Game of Thrones house names, and that's how we announce it at the things. And in future, we're considering having a buddy cop kind of setup, because we want to maybe use it to write a load of cucumber tests. And, if I haven't sold you on the idea of, how you run this competition and how easy it is, then we're just going to go through one last example. So you work in a company that has very little unit test coverage, and this bothers you. So you're like, okay, well, how am I going to fix this? Through a competition. Well, first of all, for your quick wins, you invest in a load of new unit test suites and plugins. You go out and you research PowerMock, and you come back and you're like, okay, we can test and write tests in ways that we've never done before. You sit down and you think, okay, well, it makes more sense if single developers are rewarded points by how many lines of code coverage they add. And you go to your developers, you ask them if they like it, they say no, you change a few things, and you get some solid feedback and you get everyone on board. You need something really small to motivate your developers, and you say, okay, well, a lot of the developers like coffee. You can have a special victory coffee mug. They seem okay with this. You break up your code into places that would allow for like high-level integration tests and lower-level unit tests, and then you let your developers at it, and then everything goes really well. You have this really well-tested code base now, and you say, okay, well, next time we do this, why not do it for performance testing? Yeah.
So that's really how easy it is. So I hope all of you are sitting there with a kind of at least an idea of how you might apply it yourself. I'm just going to go through some other kind of side effects we had as a result of running Sonar Smash in our office. So first up, we wrote a load of new tests. We found some really, really old issues, kind of edge cases that no one had configured in the program before and we hadn't spotted. So that was great. That's partly why some of the non-technical users wanted to take part. They were like testers and they were like, oh, these developers, they're doing their job a bit better than us. We better get on board. The next thing is that now when I open the code, I don't have monsters waiting for me. I have kittens. Like sometimes you'll get an odd scratch and sometimes it's a bit messy. But for the most part, like 80–90% of my day, I'm working in code that's refactored, which makes my life a lot nicer. The other thing that happened was we now have a mindset of refactoring. So when we come across something that is too big, for example, we had a class that was something like 4,000 lines of code, kind of a bit too big for Sonar Smash. We went to our architect and said, hey, we want to refactor this. And previously his message had been, don't touch that class, don't change it. It works, let's not go there. So he was like, yeah, let's do it. And then when it came to the teams to plan it, because they had all this experience of these smaller refactors, they had the experience to know how to break it down and actually plan it in some kind of meaningful way, which was great. And then the last thing it's done, refactoring makes you a better developer. Who knew? So now when I open a class that is messy and is horrible, I have the skills to fix it. So on that happy note, does anyone have any questions? Yep.
Would you like the question, Mike?
Okay, hello first. So how did you manage in the first step when you started to do the competition, to go in the subject? Because for the developers, sometimes it's very difficult to go in the refactor steps and so on because they don't really know how to do it. And
So I guess we started off just like blindly going forth. And then slowly people would like find a nice thing on the internet and be like, hey, like this is a nice article on how to refactor things this way, and they would like share. Yeah.
Okay, so they were motivated enough to go
Yeah.
in the-
Yeah, one thing we have now is that with more senior people getting involved, they're going back and helping some of the people who don't know how to refactor as well. And we've seen them order in like 5 copies of Martin Fowler's book on refactoring to the office, so I think that's a good sign too.
Yep.
Hi. Sorry, I think I missed the bit about comebacks. How exactly was that sort of implemented?
Okay, so we had this 2-tier scoring system, and if there was 4 teams, the most points you could get around was 4. So you would do all of your refactoring and would use that algorithm to score how well a team did, and the team with the highest score at the end of the round would get 4 points. So it meant that if we ran the competition over 3 weeks, the highest anyone could get was 16. But because it was all quite low numbers, it was very easy to catch up. So even a team that did really well in the first round, the team that did the worst and only got 1 point was only 3 points behind someone else. So when we would announce the points and who was winning in our sprint demos, we would actually hear people say to each other, "All right, we're only 2 points behind. You know, we were busy this sprint, but next sprint we're gonna get them."
Yeah.
Thanks.
No worries. Cool. Anyone else?
So hello. My question is, how did you deal with people that didn't have the mindset of competitor?
If they don't want to compete, don't make them. Like, if they don't want to be part of it, that's okay. We had people who didn't want to be part of the first one and then like actually saw what it was like and then came on for the second one. So I think, like, don't worry yourself about it. As long as like enough people are interested in it, that's okay.
Hello.
Hey.
Just one small question, maybe. You set up a competition between teams.
Mm.
Do you think this can be set up inside the team, competition between developers, or would it be counterproductive?
I
No.
think you could definitely do it.
Absolutely.
Yeah.
We think it's, you know, you can plan this on whatever level. You could have it between offices. You could have it. You could even have it. So one feedback we got once upon a time was that one team said, half of our code is in C++, half of it is in Java. How do we do that? And we said, well, have all the Java people compete against the C++ to clean up their code. And now you have Java developers learning C++ and C++ developers becoming Java developers. So.
Well, thank you guys for your presentation. It was very nice to see, very inspiring for us. I mean, for me at least. I was just wondering about how you did to compute the scores. In fact, were you doing this manually or?
So we used, you guys have, this is one of the guys from SonarQube. So you guys have an API, which, while not terribly well documented, is functional. So we used that. So we used that API, and we just wrote up some scripts.
What can I say except that feedback is a gift. Thank you, and we will do our best.
Oh, thanks very much. Cool. Anything else?
Anyone else?
Hello. Continuous to the previous question. You said cross-technology refactoring. Did this came by itself, or you just pushed them? Because in our company, it's basically Java, COBOL, or .NET. So it's a great idea, thought of it, but I don't see the necessary means because, you know, Java and .NET developers basically hate their guts.
Another way you could do it is just to like use that hatred to fuel your competition. You know, if you can come up with an algorithm that is like somewhat comparable across all the different languages, then you can do it that way. If people really don't want to pick up a new language.
I understand. Thank you.
Hi, you noted that the score for code coverage was lines of code times change in coverage.
Yeah.
Can you elaborate a little bit about the specifics of that, because terms are a little bit
Yeah,
vague.
so lines of code are lines of code as counted by Sonar. So it's not actually like how many lines there are in the file.
So lines committed, changed lines that are committed.
Yeah, new ones that are covered. So it's a way you can look it up. And then
Okay. And then the change in coverage is what?
like
is
the percentage change in coverage.
So in other words, the lines in code is the lines that they changed or the lines that they added? But we're talking about coverage of new code or coverage of
coverage of existing code. So the number of lines of code in that class by the change in coverage. So we did it that way. You might be like, oh, that's a bit odd because you should do maybe like new lines of code covered. We said like there is some irrelevant code in our program, and we wanted to kind of incentivize people to write like if you delete a load of code, you'll get a load of points. So we wanted to incentivize that a little bit. So that's the end of what we have for questions. Thanks very much for coming to our talk.
Thank you guys so much.
If you want to find us there.
If you want to find us, I'm at jmacrack on Twitter.
And I'm at Helen Finds Life. So
We're also on LinkedIn. Guys, have a great Devoxx. Thank you so much for coming to our talk.
okay.